Hello, hi. Okay, it's a very small group. I think I can just quickly go over the slide, and we can just have conversations. So quickly overview. We are the policy working group. Erica and I co-lead for the group. Motivation side, so last year, like Brian Grant also mentioned, there's a need for Kubernetes to utilize more policies to address many issues. So basically, he called for like a Kubernetes policy architecture. For us, it's like policy are like scattered around. You can see networking policies, RBAC policies. There are many policy security policies. So we are wondering if there's one architecture to look at it. So one thing we point out is that policy language is something like domain specific. So we won't get into like having a unified policy language or that. We're more interested in the, like policy semantics and control mechanisms. Like for example, with OPA, how do you leverage OPA working with Kubernetes? So this is like how we work with the larger Kubernetes community. So we talk to different SIGs, we talk to different working groups. We typically tend to have a list of running items, so we check for each meeting. Erica, are you familiar with the? I talked to Yasin about the scheduling policy and metadata policy. So do you have any updates?
I have no updates except that I've passed it off and I'm going to have someone work on it.
So yeah, so these two were owned by Yasin. He said that there was KPs, but his feedback need more rework, so he put them off. So the currently very active perspective are from Multi-Tenancy and also the OPA Gatekeeper project. We also have some long-term, we believe, very interesting areas like policy as the type system for Kubernetes, and also see if we can bring formal verification for policies. Okay, I'll just quickly go through the multi-tenancy. So there's a proposal from the multi-tenancy working group to have tenant CRD. So mostly the requirement coming from the tenant CRD design is that they want a way to more automated and freely populate all the resources that you define for a certain tenant. For example, including the namespaces itself and all the other stuff that a tenant should have. The reason for this requirement is that the current design requires that they have this template CRD as well to handle this population problem. So the multi-tenancy working group, specifically Isui from Google, asked this question would it be possible to have a policy engine help on this matter? In a nutshell, just can policy help solving the custom resource population problem? The proposal, a broad proposal here is just to use policy engine compile with a compiler, compile down to the to Kubernetes, and then with the compiler to be able to operate on the tenant policy objects, and then help basically populate the RBAC network, namespace, all these resources. The example could be OPA talking to the Gatekeeper module, and then with the Gatekeeper we have the tenant policy object that will be enforced for the resource population. So the problem is still like how to define the constraint for a population, because one of the difficulties for multi-tenant policy is that when do you hit a wall that you hit a wall of the tenant, between the tenant. Okay. Gatekeeper is like hosting OPA, but it's developing like a Kubernetes CRD solution for policy controller. We also had a case study during our workgroup meeting. So I steal this from Rita's talk the other day. It's very standard CRD design with some additional caveat of like policy template CRD and policy instance CRD. And I think this is similar to the multi-tenant problem that they use the policy template CRD to help populate the policies. If they don't have that, they have to still write the raw legal policy each and every time for every tenant. One thing I noted from OPA would be very interesting is that there's support for WASM, which I think will be pretty cool. So if policies can be compiled to WebAssembly, that's pretty awesome, just from a nerd perspective. Okay, this is something also very nerdy and interesting. So Erica and I had a discussion with AWS Automated Reasoning Group lead, Byron Cook, who is a great research in the area of formal verification. So we discussed about whether it is possible to bring formal verification to Kubernetes policy, because first of all, we want to make sure that the policy itself is defined correctly. And second of all, we want to see if it's possible to validate the policy enforcement is correct, either ahead of time or just in time. So some background knowledge, I won't read through this. So this is related to SMT, if you are familiar with the first logic, all that stuff. So basically we are defining constraints for policies so that we can evaluate them. I copied this from Wikipedia, so you can read it later. There are a couple great open source SMT solvers, CVC4 from NYU and Stanford. You have Z3, also very famous, and also Rossetti. Rossetti is actually a language can use these SMT solvers. So what the formula you see above is basically something it will look like a formal verification for the policies. You can't get more nerdy than this, I promise you. So for this direction, what we are looking at is actually basically how to build a symbolic graph for Kubernetes policies. And it is possible that for each domain, we'll have different graph representations. For example, for networking, by the way, AWS group just did a whole graph modeling for the entire AWS network. So just it's possible, it's not impossible. So for networking, it's like flows, you can flow that way, flow back, right? For multi-tenancy, like I said, it will be like a population that hit a wall. So the graph will be a little bit different. And for security, you will see something like security is parameters, right? So for the for the outer layer, you may have many acceptance, and then fewer when you go in. So possibly this year, maybe a new open source initiative, not decided yet. So we have AWS and also folks from Styra, the OPA people interested. If you are interested as well, you can shoot an email to either me or Erica. would be really cool to do this. Okay, policy.
Maybe we could actually just go back and stop there. I know, like, the multi-tenancy working group is where we get all of the people and bring on the crowd and everyone, and then the policy working group is where we get to nerd out, and because people are too scared by the name policy. But I'm really excited about the work that we're doing with AWS here, because one of the problems I think with policies right now is it's great that you have all these things. Do you know what it does even? We have security profiles or something and we say that this is a hard or soft multi-tenancy, and how can we actually know that that's what's going on? How can you make sure that all of your policies together do what you want them to do, and how can we build on top of that in a way that works and keeps the boundaries that we're looking for? That is why I'm very excited about doing some of this more formal verification of it sets the stage for automating a lot of that sort of computation and reasoning about the policies. Yeah, does anyone have questions now? We can also stop, and if you have specific questions anyone wants to bring up, please don't hesitate to ask immediately. Yeah?
Group around there, I guess. So I'm new looking at the group, and I really like the idea of formal verification, for example. That's really, really useful. But one of my interests, I just want to see if it actually fits in here, is looking at things like SOC 1 policies or financial policies, and making sure that we can formally validate that within Kubernetes, or some of the other like audit policies. Is that something that would be sort of outside of this, or in parallel, or?
It's just so many things. So they use, from a very formal verification, basically build the abstract model and test it.
Yeah.
It's pretty awesome. So financial policy is absolutely within the scope.
So some of the stuff that we're doing at JP Morgan is kind of along those lines. We've got multiple different control standards we need to meet. We've created an SDLC to sort of validate that. And then I'd really like to take it and do the formal verification. So if that's something again, if that's something of interest, I'd love to talk to you guys about it.
That'd be awesome, yeah. I know that's the big driver here. There's so slow and difficult person to really make a compliant cluster. And that's the big driver, is speeding up that process.
Yeah, another use case that might be if you are in pharmaceutical business, that you actually have using Kubernetes to do your pharmaceutical application clustering. Formal verification will be also helpful for you because it's like life and death, right?
Yeah, that's true. There's a lot. Yeah, so if we want to go in I can go into a little bit of, well, how are we thinking about policy? What is considered a policy? It's a very broad term that gets thrown around a lot. And we want to distinguish kind of policy from security or from configuration or many of the other kind of aspects that kind of get blurry to people. So in a kind of formal way, we're talking about, we have subject identity, a rule set that maps the outcome and maps the identity, the rule, with the current state into some kind of decision. That's the kind of like basic. So there's rules that are making a decision based on the input of the subject and the current state. One of the things we're kind of thinking about is what has worked traditionally for policies and making sense of this and what hasn't worked. Why have some systems caught on and worked out better than others? In particular, I asked, why does SE Linux seem to mostly work, even though no one can understand it? And why did that catch on as opposed to there's a lot of other, more advanced in some ways models? And it was that it's actually really just a type system, and that this is one of the easiest ways for us to reason about things. And that we could bring that in. We already have, much of Kubernetes is based on the idea of these resources that are typed somewhat, and how we manipulate those objects. The next part, of course, is we have certain places that we want to hook into the policy. Where are these decisions being made? Can we make sure that those access points are defined well? So the policy hooks, we have the lifecycle, network, pod. We have about 5 spots that kind of the policy gets enforced at. Good, next. Another thing that I would like to explore more is kind of a capabilities-based access control model to delegate authentication and authorization more easily. This kind of ties into how do we trace the state, including across the objects in Kubernetes. Capabilities are kind of like you have a token that you keep passing on. The access to the object, it has this kind of token which defines, so how to access it comes along with the scope of access and its kind of state. So this sort of ties into how we can better utilize our JOTs if we want, or tie in with the pod identities of SPIFFE and more. Another kind of difficult the thing in Kubernetes that we are trying to reason about is how dynamic, or what, Kubernetes is very flat, and I think we should keep it that way. There's great projects like OPA that you can use to build on top of Kubernetes or any other kind of framework, but etcd is an eventually consistent, flat kind of state of the world, and we shouldn't if we get away too far from that as Kubernetes policy objects, we lose track of what our guarantees, I think, really are about the system, if that makes sense. Then some other little proposals, namespacing everything. That makes just some kind of immutable labels or annotations, and better ownership, chains. Those are some specific proposals. So we're starting kind of with the formal verification, so maybe those ones will come later. Yeah, this is the CNCF now has a SIG security, which I recommend. I don't know, they already had the deep dive, huh? But there's so many great projects in the ecosystem. You want to talk about it?
Sure. I think this is the first SIG in CNCF. So the security SIG basically covers 2 broad areas. One is, of course, security. Justin from NYU and Justin Cormack from Docker and folks are helping with the security assessment for projects. I think they have done for TUF, Notary, and SPIFFE. Yeah, they are doing it now for OPA, and there's something in the pipeline as well. Another broad aspect is, of course, policy. That's why we are here. We try to figure out a overall architecture for the whole cloud native system. It's not only for Kubernetes, but also, you consider things like Cilium, Spiffy, Istio, Mesos, Docker. You put all the things in perspective. This is something we came out for the moment. So we think it could be 3 layers. We have the typical control layer, like Kubernetes, right? And the data plane, Cilium or like Envoy, that actually dealing with the flows, data flows. And at the upper layer, we have the policy layer. We have policy engine, like OPA. And we have the compiler, like, it's not compiler in the like programming language sense. So it's compiler that could compile policy down to what Kubernetes understand. So compiler here, one example could be the OPA Gatekeeper, the CRD compiler option, and also formal verification engine that we are looking at. So these 3 basically forms a loop that could help you like write policies, verify policies, and enforce policies. Okay. Last but not least, get in touch with us. We are a small, very persistent, but sometimes passive-aggressively scheduled working group. Just give a shout out on the either meeting note, or we have Slack channel in Kubernetes, or the CNCF channel, Slack channel. Both could work. We are doing case study. It's like podcast. It's very interesting to do that. So if you have, or you've been working on any project that you think is policy related, we can do like case studies on that. And also if you have like research directions like formal verification, these type of very nerdy things that we like in our group. And also if you have KEPs that dealing with policy, you can add working group policy labels there. So we are both the KEP reviewer, I think, now. So we can help. Okay. That's the bulk of the presentation. Now we can chat. Any questions, or just talking?
Yeah, I'm always, interested to know why did people decide to show up here? Like, what is your interest in policy? Do you have specific pain points that you would like to see addressed, or ideas? Anyone? Yeah. Yeah, that's one of the problems, definitely. It's like, well, I'll just add something with a higher priority then, and it starts stacking up, and these can, grow, and you kind of need to then squash them down somehow, and then, that's good to hear. It's always really one of the things we need more of is stories of, in production uses of what the reality is like. I can talk about it, what my reality is like from the OpenShift side, but the more use cases, the better, because that can really help inform our prioritization. Yeah. Yeah. Yeah, we'll put it on the, I think like, yeah, in the schedule thing. Yeah, yeah, we'll attach them. Yeah, sure. All right.
This might be the most technical mathematical things you see. You're very lucky.
Yeah.
Okay, thank you.
Thank you.